Hello there. Welcome to Engineering Drawing Made Easy.
Today we are going to work on this figure here. Now, if you study it carefully, you see all the various parts that we need to draw or would need to replicate. Yes, we have this circle, we have this circle here as well, and then we have one arc here, and we have one arc here, and there are these two lines, center lines that shows the relation between how those two circles meet in both ends. So we are going to start working on this. First, I'll start by drawing this center line because I have this circle on it here and this also in relation to that same center line. Now, if you look carefully, uh, it says that the distance between the center of this circle and the center of this circle is 77 millimeters, right? So we mark out that distance, and at the end of both um, points on the line, we can draw our circles. We go on to the next thing, which will be drawing this arc here. It says at the center you have a radius of 23, and then you draw that arc. The next easiest component to draw will be this particular arc because it's also in relation with the center line you drew, and it has its center 13 millimeters away from this line. So it touches the line at exactly one point, and the center is 13 millimeters away. Now, the next thing will be to draw this arc. Now, if you study carefully, this arc has a radius of 58 millimeters and it touches this circle at one point on this given line, which is parallel and at a distance of 10 ml from this line. And they also, the same arc also touches this particular arc at a internally, right? So this one is the one with the distance of 10, but then this touches the arc internally. So first we start by drawing this parallel line. Yeah, so this is supposed to be some sort of center line. The next thing to do is to extend these arcs so that they touch or meet the new center line.
If this lesson is helpful so far, don't forget to subscribe so you don't miss upcoming tutorials.
Now, moving on to this arc. This arc touches the circle and meets at exactly this point. And from a point to the center of the circle will be same as the radius, right? So that would be from here looking up to 58 millimeters, and that would give us an idea of where the center should be. And when we come back here to the rules of tangency, 58 minus 13 because they are attached internally, that will give us like 45. Then from here we draw another arc. We're about 60 or 70% done here. So let me know your thoughts in the comment section, and if you have any questions too as well, you can leave them in the comment section. Yeah. Also help the channel grow by subscribing and liking the video if it's helpful. The next thing will be to work on this last arc here, right? And similar to what we did here, is this is going to be the same approach. The distance from this point to the center is the same as the radius, and then from here to the center is the difference between radius of 83 and radius of 23, which is 60, right? 60 millimeters. So from here to the center is 60, from here to there is 83. Just let me just extend this, make it long enough so that we'll be on the safe side. Yeah. Yeah, so that is it. This is how you work on this tangency problem. And as I've always been saying, depending on where you find yourself, there might be requirements of what your lecturer or your teacher expects of you. Like some people prefer to see the constructional lines so that they understand exactly what you did. Some people are not that much interested in that. So you have to find out what your lecturer is looking for or teacher is looking for, then do exactly that, right? I'm just going to claim most of the lines that are not part of the work, and then you see how they figure more. So that'll be all for today's video. Kindly subscribe, share, and see you next time.